Hello again. Welcome to another lesson in geometry. Today we're covering section 8-1, the Pythagorean Theorem and its converse. All right, so this should be mostly review for you. Let's take a look through it anyways. Write the square and the positive square root for each number. So the square of 9 is 9 squared, which is 9 times 9 for 81. And the positive square root of 9 is what number times itself makes 9, which is 3. So this is really 9 squared and the square root of 9. And notice they said the positive square root of 9 because remember, when you square root something, you have the principal square root, the positive one, but you also get the negative one. And that's because this really says what number times itself makes 9, and there are two answers for that. There's positive 3 times positive 3, but there's also negative 3 times negative 3. All right, so then what is the principal square root of 1/4? So what number times itself makes 1/4? And that's going to be 1/2. Okay, so all we want was the positive one. So some vocabulary builder here. In a right triangle, we have the hypotenuse. The hypotenuse is the longest side of the right triangle. It's always across from the right angle. And we also have the two sides that touch the right angle, are adjacent to it, are called the legs. Okay. All right, so the legs of a right triangle are perpendicular to each other, and the hypotenuse is the side that is opposite of the right angle, the one across from it. Okay. Number 2, underline the correct word to complete the sentence. So the hypotenuse is the longest side of the triangle, right triangle. The one across from the right angle will always be the longest. By the way, for any triangle, the longest side is always across from the longest angle, and the shortest side is always across from the smallest angle. Okay. All right, so write T for true or F for false. The hypotenuse of a right triangle can be any of the three sides. This is definitely false. The hypotenuse is always the one opposite of the right angle. One leg of a triangle at the right has a length of 9, and this is true. Remember, this is our hypotenuse, and these are our two legs, and one of them is 9, so this will be true. And the hypotenuse of a triangle at the right has a length of 15, and that is also true. Okay, the hypotenuse is the one across from the right angle, and it's the longest side, and it has length of 15 in this case. All right, theorems 8-1 and 8-2, the Pythagorean theorem and its converse. Pythagorean theorem. So if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. All right, and we'll see some proofs about this as we go along, but basically it's saying, hey, if you were to square, in other words, draw squares here, so look at the area of these three squares. This big square formed by the squaring of the hypotenuse has the same area as these two little squares put together, formed by squaring the legs. Okay? And if you were to cut out those two little ones, you could lay it exactly on top of the big one, no matter what right triangle you picked. Okay, and that's what this says. The sum of the squares of the legs equals the square of the hypotenuse. And you saw this many times throughout 8th grade math. Okay, so the converse of the Pythagorean theorem says if the sum of the squares of the lengths of the two sides of the triangle is equal to the square of the length of the third side, then we know that it's a right triangle. So if you take the big side, just given any three old sides, and you square it, and then you square the other two and add them together, and it all makes sense, okay, it fits this equation, then you have a right triangle. So one way is given a right triangle, we can find the legs, and the other way is given all the sides, we can tell it's a right triangle. All right, so number 6, circle the equation that shows the correct relationship among the lengths of the legs and the hypotenuse of a right triangle. So remember, the long side always has to be by itself. So in this case, this is like saying the hypotenuse and one leg added together squared should equal the other leg. That doesn't work. And the last one, same kind of thing. This is the hypotenuse because it's the longest side. It has to be by itself on one side, and the two legs need to be together. So here's the hypotenuse, the longest side squared, and here are the two legs squared and added up. So the sum of the two legs squared. Underline the correct words. Oh, we have to circle this. This is the correct one. Okay. Underline the correct words to complete each sentence. A triangle with sides length 3, 4, and 5 is a right triangle because 3 squared plus 4 squared is going to be equal to 5 squared. So let's just show that. 3 squared is 9. 4 squared is 16. Together they add up to 25. And over here, 5 squared is just 25. So the two legs, the sum of the two legs squared, which is 25, equals the hypotenuse squared. So we have a right triangle. Okay. A triangle with side lengths 4, 5, and 6 is definitely not going to be a right triangle, because 4 squared plus 5 squared, this is going to equal to 16 plus 25. I think that makes 41. And that's definitely not equal to 6 squared, which is 36. Okay, so remember, if the two small sides squared added together do not equal the big side squared, then you don't have a right triangle. That's what the converse of the Pythagorean theorem says. All right. So we have a problem down here about finding the length of the hypotenuse. Okay, the legs of the right triangle have lengths of 10 and 24. So we'll put 10 on the one that looks shorter and 24 on the one that looks longer. What is the length of the hypotenuse? And the hypotenuse is always going to be across from the right angle. So there is our hypotenuse. And you'll often see the letters A, B, and C, but it doesn't really matter. Just think of the two legs added together equal the hypotenuse on the other side if everything is squared. All right, so in our case, A and B can be either 1, 10, or 24. So we'll put 10 first and 24 second. Those are our legs, and they're squared and added up, so they should equal the hypotenuse squared. So 10 squared is 100, and 24 squared is, let me get my calculator out here, 576. If you add them together, you get 676. And then the square root of 676 is 26. Okay, and notice we were asked to take the positive square root, so we ignored the negative. And that makes sense in our case because the length of a side of a triangle can't be negative. So it's going to be 26 units. So the length of the hypotenuse is 26 units. Okay, so one Pythagorean triple is 5, 12, and 13. Okay, and that's because 5 squared plus 12 squared equals 13 squared. This works. It's called a triple because these are all whole numbers. Okay, so 3 whole numbers together that make the Pythagorean theorem work is called a Pythagorean triple. If you multiply each of those numbers by 2, what are the numbers result to? So this would be 10, 24, and 26. How do the numbers that compare to the lengths of the sides of triangles used in exercises 9 through 11? Well, these are the same. Okay, so if you take a Pythagorean triple and you double all the sides of it, you're going to get another Pythagorean triple. Okay, that's what this looks like. All right, let's flip it over and look at the next page. Problem number 3, finding distance. Okay, this is a got it question, so we want to see, did you understand the Pythagorean theorem from the last 2 pages? And our problem says this: the size of a computer to monitor is the length of its diagonal. You want to buy a 19-inch monitor that has a height of 11 inches. So when you read a box for a new monitor or a new TV, they always tell you the diagonal. So this is the 19 inches, and we found out the height is 11, and we want to know what is the actual width of our monitor. Okay, so this is our unknown. So label the diagram at the right. So we've already done that. And then number 14, the equation is solved below. Write a justification for each step. So our first thing is this is just the Pythagorean theorem. All we did was write it down. So Pythagorean theorem. Okay. Our second step, well, we just plugged in the numbers we knew. We knew one of the legs. We knew the hypotenuse. Now, it doesn't matter which place you put the leg in. So you could have done, you know, like x squared plus 11 squared equals 9 squared. Or you could have done 11 squared plus x squared equals 19 squared. It doesn't matter. Okay, so you substitute leg in either spot you feel like. Okay, but this is still the substitution property. Okay. All right, so we simplified 11 squared and 19 squared. So that's just squaring something, so that's simplify. All right, and then we're going to subtract 121 to both sides. So that's the subtraction property of equality. All right. So then we end up with b squared equals 240. So that's after simplifying both sides. So doing this subtraction and this subtraction. And then we get b is equal to the square root of 240. So this is take the positive square root. So all right, and then we use the calculator to simplify the last part. So positive square root to both sides, and then this is a little calculator work. Okay, so to the nearest tenth, how wide is our monitor? So remember, we look back to the hundredth spot, which is 2 decimals back, and this 9 will tell us to make that 4 get 1 bigger. So our monitor will be 15.5 inches, about. Okay. All right, problem number 4. A triangle has side lengths of 16, 48, and 50. Is the triangle a right triangle? Explain. Okay, so how could we tell? Well, first off, we need to figure out which one of these 3 sides is going to be our hypotenuse. So this is the converse of the Pythagorean theorem. We're given 3 sides, and we know it's a right triangle. This has to be our hypotenuse. It's the biggest side. Okay, so that means 16 and 48 are going to be our legs. So when we plug into the Pythagorean theorem, to test, we want to make sure we get the 50 by itself on one side. So this one's wrong, this one's wrong. We want to use this equation. And then we're going to simplify our equation. We're testing here, so notice we're not solving. So we have 16 squared plus 48 squared, question mark equal to 50 squared. If we do 50 squared, we're going to get 2,500, question mark equals. 16 squared is 256. And 48 squared is 2304. All right, if we add up on the left side here, will we get 2500 again? And we don't. We get 2560. So, given this math, what are we going to say? Is this a right triangle or not? So the equation is false. These are not equal, so this is bad. And that means that this is not a right triangle. All right? Now, we looked about Pythagorean triples on our second page, I think, and we kind of discussed it a little bit, but here's a definite definition here. So a Pythagorean triple is a set of non-zero whole numbers, so A, B, and C all have to be whole numbers, so no decimals, that satisfy the equation of A squared plus B squared plus C squared. And then they gave you an example where we doubled all the sides of a Pythagorean triple, and we found another Pythagorean triple. And this is because if you multiply a Pythagorean triple by any other whole number, so all 3 sides by another whole number, you'll get a new Pythagorean triple. So it doesn't have to just be doubled. It could be tripled or times by 4 or times by 5. All right, let's flip it over and see what's on our last page here. So we have one more theorem up top. Theorems 8.3 and 8.4, the Pythagorean inequality theorems. So this lets us know what kind of triangle we have based upon whether the hypotenuse squared is bigger or smaller than the leg squared, whether we're going to get an acute or an obtuse. So remember, if it's equal, we have a right triangle. Now we're going to find out which one's which for not equal ones. So theorem 8-3 says, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other 2 sides, then the triangle is obtuse. So if the longest side is bigger than the sum of the other 2, so that means the longest one is what would normally be our hypotenuse. Now this is going to make this be the biggest angle. So the longest side is always across from the longest angle. And if it's bigger than the other 2 put together, then it's an obtuse triangle. Okay. Theorem 8-4 says, if the square of the length of the longest side of a triangle is less than the sum of the squares of the other 2 sides, then we have an acute triangle. Okay. All right, so let's take a look at this in words here, or math symbols. So in triangle ABC, the biggest side squared is bigger than the 2 legs, other 2 sides squared. So triangle ABC is going to be an obtuse triangle. Okay. And in number 20, RST, the biggest side, okay, that's over here. If I square it, it's still going to be smaller than the other 2 smaller sides added together squared. Okay, so in this case we have an acute triangle. All right. So last thing is a lesson check on the Pythagorean theorem and its converse, and the Pythagorean inequality theorem. Okay. So make sure you don't forget about that one tomorrow. All right, so as always, pause the video, try the lesson check, and then come back. Okay, welcome back. This is a do you understand lesson check. So we have an error analysis here. A triangle has side lengths of 16, 34, and 30. And your friend says, hey, this is not a right triangle. So look at your friend's work over here that's been crossed out and help describe the error that they made. So they had these three sides and they wrote this first line for the Pythagorean theorem. So think about what's wrong with that. Okay. All right, number 21, underline the length of that your friend used as the longest side. So our friend used 30 as the longest side. And circle the length of the longest side of the triangle though. The longest side of the triangle was supposed to be 34. So where our friend put 30 in the equation, they should have had the 34 there. Okay. So write the comparison that your friend should have used to determine what the triangle is a right triangle or not. So they should have used 16 squared plus 30 squared question mark equal 34 squared. And then describe the error in your friend's work. My friend did not use the longest side of the triangle correctly. Okay. All right, so check off the vocabulary words that you understand. We have hypotenuse, leg, Pythagorean theorem. These should all be old news for you, okay? Pythagorean triple should be a new one. And then you should also know about the Pythagorean inequality theorem up here, okay? That's probably new for you also. So you need to be able to tell, is it going to be acute or obtuse tomorrow, all right? So rate how well you can use the Pythagorean theorem in its converse, and you should be up here by now. All right, I'll see you in class.